Hello and welcome to this short tutorial on how to use Chef Cipher and Affine Cipher. Cryptography is the process of converting ordinary plain text into an intelligible text so that only those whom it is intended can read and process it. This is very important applications in computer science in making sure online systems are secure from third parties called adversaries. There are two processes. Encryption is the process of translating plain text data or plain text into something that appears to be random and meaningless or ciphertext. Decryption is the process of converting ciphertext back to plain text. Suppose you would like to send the message, "Meet me at this usual place," to a friend, and you would like to encrypt it so even if it gets intercepted, no one will know what it is except your friend, who knows that K to be 7. To encrypt this using the Chef Cipher method, we assign the numbers from 0 to 25 to the letters in the alphabet as shown. Next, we determine the numbers corresponding to the letters in the message. So M is 12, E is 4, again E is 4, T is 19, and these are the rest of the numbers. Notice that these numbers represent their positions in the alphabet. Next, we use the K, which is 7. In this case, to move the letter 7 places to the right, this is achieved by adding 7 to the original position. So 12 plus 7 is 19, 4 plus 7 is 11, 4 plus 7 is again 11, 19 plus 7 is 26. And these are the new positions of the other letters. The next step is to find the letters in the new positions. But there's a problem. We don't have the letter corresponding to 26 and 27 in the new position. This is where we take mode 26 of these numbers. 26 because there are 26 letters in the alphabet and we are using mode to make them revert back to 0. After 25, so 26, mode 26 is 0 and 27 mode is 1. And this is now the encryption of the message by key equals 7. This is obviously an intelligible phrase that can only be decoded by someone who knows what the key is. Now, let's try decrypting Lockheed's fib using the K equal to 10. Still, using the same number assignments, these are the numbers corresponding to the letters of the word we want to decode. Take note that these are the shifted positions and we would like to put them back to the original positions. And we do that by subtracting the numbers by 10 and the results are shown. Notice that we don't have letters in the negative positions. So again, we take mode 26 of this negative number 6. Mode 26 is 20. Negative 7 mode 26 is 19. And again, negative 6 mode 26 is 20. When we take the letters in this position, we get the letters in this position, we get the word beautiful. And that's how we encrypt and decrypt using Chef Cipher method. And this time, let's proceed to Affine Cipher. The K from an Affine Cipher is going to be alpha and beta, are numbers. And there are 3 requirements for alpha and beta. 1. The GCD, the greatest common divisor of the alpha, and 26 must be 1. Now, the reason between alpha and 26 is because I'm using the English alphabet which has 26 letters. Therefore, I picked 26. If I were using an alphabet that had 30 letters or 30 characters, it would be the GCD of alpha and 30. However, many symbols or characters you're using, that's the number you want the GCD of alpha and the characters to be. 1. Second requirement, alpha must be in between 1 and 25. 1 is okay, 25 is okay. Anything in between real whole numbers. No fractions or anything like that. So you can't have like 26 or something like that. 3. Beta must be in between 0 and 25. Same requirements for that. No fraction or anything like that. So how to encrypt using Affine Cipher? We use this function here, f of x equals alpha times x plus beta, where X right here is the plain text letter, so it's the number that has not been encrypted yet. We call that the plain text. The alpha times X plus beta is the ciphertext or in the new letter. Now I am going to give an example of how I actually do this. I wrote her encrypt G and our key is 7 and 2. First thing we need to do is encrypt G. What number is G? A through Z. And then under them, I just number them starting at 0 normally. You can start 0, not 1. So A is 0, B is 1, C is 2. Etc. And then I can find J here is 6. So I'm gonna write that here J is 6. So I'm going to use my function f of 6 equal alpha times 7 times 6 plus beta, which is 2. And that equals 44. Now normally what we would do is we would take this 44. You may notice 44 is not an option. It only goes up to 25 here. So what we have to do is we have to subtract. We have to use modulus. We're using modulus of 26 now. 44 minus 26 equals 18. 18 is S. So we can say that G, which when it gets encrypted, goes to S. Thank you for taking time to watch my video. Bye bye.